Okay. There is only one doubt that has been raised in the previous this one. I hope in the problem that is being stated, -8 into I2 minus I1 has been taken because I1 and I2 are the loop currents that have been considered in clockwise direction in each of the loops. So according to Maxwell's circulating current theorem, it is algebraic sum of the currents. So for that particular loop, we have to take. And that is I have stated, but the question that is being asked is suppose it is there. Okay, if you choose the other direction, the circuit current will not change, should not change because it is only alternative method. The current, only the process equations might change and the solution methodology also will be similar exactly. And as per the calculation, you will get the same current flowing through the corresponding elements. That cannot change. And that question of negative sign will come only when the both are in the same direction. That is, I1 is taken in clockwise direction, I2 is in anti-clockwise direction. That is only this one. That is only question that has been asked. That is why just I started with that. Anyway, and again, candidate if he has registered already, and this one you can know it easily. Anyway, today I would like to discuss the now. It is 3 o'clock. So I will be just starting on the continuation of the two-port network parameters. So we know that it has been classified into 6 parameters, out of which I have discussed the impedance parameters and admittance parameters. And the other one which I would like to discuss in today's class are transmission parameters and hybrid parameters. And after this, this will take about 45 minutes to 1 hour. Then I would like to go to the transients. So transient subject today and probably tomorrow also to some extent I may have to cover. So after this discussion of the transient parameters and hybrid parameters for about 45 minutes to 1 hour, few simple examples have been also considered. So after that I will discuss the transients, that is DC transients or AC transients, that I will discuss at length. And and today now I am starting with the transient parameters. So here the V1 and I1 at port 1 are expressed in terms of V2 and I2. So V1 is equal to A into V2 plus B into minus I2. I will tell you the reason for this. I1 is equal to C into V2 plus D into minus I2. So minus I2 implies port current is away from the port. Current will be away from the port that will generally obtained. That is why these are called transmission parameters. Imagine it is a power system network. Then current flowing from the 2 to 2 dash is the receiving end current, and V1 I1 are essentially the voltage at the sending end, current at the sending end, and minus I2 implies it is not the negative current, sign convention is away from the port. Current into the port is taken as positive, so therefore receiving end current is expected between the port 2 to 2 dash, so it is minus I2. So same notation, not that B or D are negative, because we will be saying that we may be thinking that A into V2 minus B into I2, suppose we write, then is it B and similarly I1 equal to CV2 minus D into I2 if we write, or B and D are negative. No, they are not negative quantities. Now, that is what I have written. In power system applications, V1 is equal to Vs, I1 equal to Is, minus I2 equal to IR, and V2 will be equal to VR. So that is the clarity I am giving with respect to the notation that is being used in circuit theory and as applied to the power system. Now, what is the definition of A? These are called ABCD parameters. V1 and V2, V1 and I1 is the port 1 voltage and current, input voltage and input current. Port 2 output voltage and output voltage and output current. And A is equal to V1 by V2. So in some text, actually it is called voltage ratio. In some textbooks called reverse voltage ratio. What is reverse voltage ratio? If V2 by V1, generally the ratio are being taken from output by input voltages. Okay, so that is the reciprocal of that is taken here by notation only. It is reverse voltage ratio with RE, that is receiving end open circuited. I mean here RE means receiving end. Receiving end is open circuited. That is port 2 is open circuited. Okay, so that means when I2 is equal to 0, the ratio of the V1 by V2 input voltage divided by the output open circuit voltage at port 2, or in other words, the sending end voltage divided by the receiving end voltage when this receiving end is port is open circuit. That is how we can discuss with respect to the power system applications also. Then that is why they are called transparent parameters because of that reason. A B is equal to, or let me explain C. When I2 is 0, then C equal to I1 by V2. So again, V2 by I1 is forward transfer ratio, and then that is why this is called transfer admittance. That is why this is called reverse transfer admittance in some textbooks. Otherwise, it is called transfer admittance in general. So it is a ratio of the input port source excitation current divided by the V2. That is V2 is the voltage, and at the receiving end it is it is I2 is 0 means open. I am sorry, there is a small mistake here. So I2, I1 by V2 when I2 is 0. Yeah, it is open circuit, not short circuit. Is corrected. And D is equal to, similarly B is equal to when V2 is 0. When V2 is 0, V1 by minus I2. I told you the reason. If current is away from the port, that is taken as minus I2. Current into the port is of course the positive value of the I2 that is being chosen. So this is the reverse transfer admittance. That is, it is equal to transfer admittance. Okay, with receiving end is short circuited. And D is equal to I1 by minus I2 is equal to, and I1 by minus I2. So it is reverse current ratio, or simply the current ratio with the receiving end is short circuited. So here small mistake is there. This is to be corrected as open circuit. And for a passive network, the parameters will be positive. The parameters will be positive. And AD minus BC is equal to 1. That is a standard relationship. Okay. This is one of the important relationships that is there for the transmission networks. Always it has to satisfy for the passive and reciprocal network. Again, it is for reciprocal network means the ratio of excitation and the response, if you want to consider to be in the opposite nature. That is called reciprocal network. So remember that, which we are not discussing, but for the same network, we are defining all the 6 type of parameters. Please remember this. So therefore, there is interchangeability of the corresponding network parameters. That means what I mean to say, interchangeability or interrelationship between the quantities is transient parameters can be represented in impedance parameters or admittance parameters or hybrid parameters, etc. So I told yesterday that each of the parameter can be expressed in terms of the each of the other parameters, right? That is the meaning of interchangeability I would like to discuss and mention. And that is how we can get the interrelationship. That we are not discussing at this stage because so far I did not see any gate question paper. In the gate question papers, the given some of the parameters, how to find the other parameters. But directly from fundamentals only it has been asked so far. So I am skipping that particular part because otherwise I told you there will be so many points to be discussed. But in a span of 12 days, what best we can do crisply and to the point only. I would like to give these points. Which one I am skipping also I am telling. If time permits at a later stage, if you want that clarification, we can give at a later stage. I have given my email ID also. But any doubt you have got, don't ask me to pose a problem and then ask me to do it. Instead of that, you do the problem. You can send the scanned copy by mail subsequently after the 12th day. Then we will try to discuss that. You have got a doubt whether it is correct or not. It's not that you are giving assignment to me. Okay. Somebody is asking me to explain. You explain this method. You explain that method. Okay. It is not individual. So commonly we can discuss only a few points of for all because a few hundreds of students are attending to this particular one. Actually, every point to be mentioned, every doubt has to be cleared. But time also we have to see. Okay. So anybody want to have such clarifications, you have got a doubt, you have a problem of the gate or other examination question paper, solve it and send it, then we can verify where you have gone wrong and other things. Okay, that is only of correspondence at this stage. So anyway, so now let me go through simple examples in this. The ABCD parameters of an ideal N:1 transformer. This is a very typical problem which is given in GATE 2005 for 1 mark. The ABCD parameters of an ideal n is to 1 transformer shown in figure are n0, 0, x. The value of x will be, so this is the transformer notation. V1 is the input voltage, I1 is the current, I2 is the corresponding one, V2 is the secondary voltage, this is primary voltage V1. So that we know the terminology. So the transformer is taken as a two-port network here. So the options are n, 1 by n square, 1 by n square. I repeat, by the time you can make a guess, do not go through the solution directly. Try to make a guess of the answer and then I will explain anyway. The ABCD parameters of an ideal n is to 1 transformer shown in the figure are n, 0, 0, x. The value of x will be. So how do we obtain that? So the answers that are given are n 1 by n square, 1 by n square. So by looking at this, I can compare this with the conventional ABCD matrix. So that is V1 I1 is equal to A, B, C, D into V1 minus I2. That is how we write the equations in matrix form. Already two equations are known. That is V1 is equal to A into V2 plus B into minus I2. I1 is equal to C into V2 plus D into minus I2. I have not changed anything. I have put them in only in simple matrix form. So comparing, this is given as the ABCD parameter matrix. So A, B, C, D must be same as N, 0, 0, X. So equating the appropriate terms of the first row, first column, first row, second column, second row, first column, and second row, second column elements respectively, each one. So N must be equal to A. B and C are happen to be 0. Okay, B and C happen to be 0 for the given network, and D is given as X, which is unknown. So the only relation which is to be invoked into this particular one for calculation is AD minus BC is equal to 1. So N into D equal to 1. So that is N into X must be equal to 1. So X is equal to 1 by N. So therefore B is the answer. So by comparing the corresponding quotients of the matrix which is given for the ABCD parameters, A will be equal to N, D will be equal to X. So AD minus BC equal to 1, and of course BC happen to be 0 here. So N into D equal to 1. So N into X is equal to 1. Therefore X is equal to 1. That is why I said it is a simple problem. But by looking at one may think that the transformer problem, what is this, how it is related and other things. We should not worry about the extra these things that have been given. Most of the time, that is one which is corresponding to the question what type of data is that. Actually, this transformer representation need not be given. Okay, this is only parameters of a particular. This one is there. So, what is the corresponding value of the x? Simply could have been asked without referring to a transformer. But if because having got the knowledge of the transformer also, you should be able to understand the difference between the approach in finding the parameters. Okay. So we have never tried for finding a transformer parameters, right? Parameters, ABCD parameters for a transformer. But that is typical. That is why you have to, how the transformer parameters, is there any transformation ratio to be calculated, other things we used to worry. But based on the question that is being given, what is relevant to the question, how to attack the problem is the point of interest in get object type questions, right? So that is a typical question here. So it is n is to 1 this one. So the value of the D, that is the, what is D you can see. D is the I1 by minus I2, reverse current ratio. That is the current ratio of the input port to the receiving end port or port 2 and the receiving end is short circuited. Okay. So that is the current ratio. So the current ratio will be equal to 1 by N. That is satisfies with the transformer principle also. Right. So because we know V1 into I1 is equal to V2 into I2, the KVA will be same, right? So therefore, okay, those things anyway, I'm going beyond the scope. But anyway, comparing the corresponding ratios, you can see it is 1 is to N. So that is 1 by N. So just by comparison of the quotients of A, B, C, D, B, C happen to be equal to 0, A equal to D, and therefore N into X is equal to 1, therefore X is equal to 1 by N. So this is a typical problem that I got in the GATE questions, which is given in the book by Electronics Engineering and question and answers, made easy publication, MEP, made easy publications. So some typical problems I'm explaining here. As I told you, we have been lucky to get one of such textbooks for this pandemic period to for better illustration through online. through online. Next one. A two-port network is represented by ABCD parameters given as. So V1, I1, A, B, C, D, V2 minus I2, same, already it is given. If port 2 is terminated by RL, okay, that means it is equivalent to, I will tell you, by RL, the input impedance seen at port 1 is given by, therefore our 4 options are being given. It is like a derivation, but it's not so. If you understand the clarity of finding out, it's not a difficult problem. Okay. You can see this is the given network I have drawn based on this particular one, given the equations. So RL is connected. That is meant by terminated by RL. This terminated by RL is used in power system applications also. Electrical wave is terminated at the load resistance end by inductance or open circuit and by resistance. All those things are being terminology that is being used. Okay. So now if port 2 is terminated by RL, that is it is equivalent to connecting a impedance value of RL, that is resistance value of RL at port 2. That is the meaning of that. So so alternative terms or synonymous terms are where it can be specific terms to the problems are being given in the gate because you have to understand that they are to be appropriately to be understood. The input impedance seen by port 1. What is my input impedance? V1 by N1. V1 by 1 ratio is called the input impedance, right? So, or driving point impedance, and when I2 is made 0 in this particular case, right? So V1 by 1 is equal to, because V1 by 1, sorry, it's not that. V1 by 1 is input impedance because V1 when you obtain, you can write down the equations of A V2 plus B into minus I2. And we know now it's not I2 dash, it looks like that, but the dot extra has been placed there. So V1 is equal to A into V2 plus B into minus I2. I1 is equal to C into V2 plus D into minus I2. So now within this V1 by I1, V1 is the input voltage at port 1, I1 is the port 1 voltage with V1 by 1 ratio, whatever the name that is being given, we can find out easily like this. So V2 now can be represented as, again, do not get confused, port 2 is, when you say about the current through the resistance RL, then it has to be away from the port, 2 to 2 dash. This is 2 implied, this is 2 dash. So current into the port is taken as positive, therefore the current has to be in the receiving end side from 2 to 2 dash generally. So therefore it is taken as minus I to RL. Always sign conventions, people should not get panicky. Several questions have been asked on this, but you have to be careful about what we are talking about, what measurement we are making, or what voltage you are considering across what points and other things. So here V2 is equal to minus I2 into RL. So therefore V1 is equal to A into V2 plus B into minus I2 means V2 by RL. So similarly I1 is equal to C into V2 plus D into minus I2 is V2 by RL. So taking this one, V1 by V2 is equal, V1 by I1 is equal to A V2 plus V2 by RL into B divided by I1 is equal to C into V2 plus D into V2 by RL. So therefore, taking the ratio V1 by I1, because everywhere V2 gets common, both numerator and denominator. So this is A plus B in by RL divided by C plus D by RL. So therefore, you get the cross multiplication of these things. RL into A plus B divided by RL into C plus D divided by RL. Both numerator is 1 by RL, denominator also I got 1 by RL that way. That get cancelled. So ARL by ARL plus B by CRL plus D. So that is the ratio of the V1 by I1 that can be computed. So the source impedance, due to the transparent parameters that can be obtained as V1 by I1 ratio is equal to like this. So this is a typical question. This is being given in 2006. So these are some of the typical questions that have been given. A two-port, I repeat, a two-port network is represented by ABCD parameters given as V1, I1 has A, B, C, D, V2 and minus I2. If port 2 is terminated by RL, the input impedance seen at port 1 is given by this one. So V1 by I1 is the referred to as input impedance, right? So V1 by I1. V1 is expressed in terms of A into V2 plus B into minus I2. I1 is equal to C into V2 plus D into minus I2. So V2 is equal to minus I2 into RL. The circuit has been drawn here. So RL is the corresponding load resistance that is terminated, means that is connected. That is the meaning which you have to take. So V2 is equal to minus I2 into RL. So substituting V2 by minus this minus I2 is equal to V2 by RL in this equation of the first one. I1 will be equal to V1 will be equal to A into V2 plus V2 by RL into B. Similarly, I1 is equal to C into V2 plus D into minus I2. So substituting minus I2 equal to V2 by RL, we will get this CV2 plus D into V2 by RL. Okay. So V1 by V2 is equal to the input impedance at port 1, which is equal to A plus that is A into V2 plus V2 by RL into B divided by C plus divided by I1, that is C into V2 plus D into V2 by RL, V2 getting cancelled in both the cases. So therefore, that means when you have measured, when V1 is excited source, because why that input impedance, again I have to do the clarity, because when V2 is being measured implies that when the load resistance is connected, okay, not when port 2 is open circuited. When you can get from that also, there is another derivation is there. But anyway, so when this is directly being connected, because this we have tried to solve when I was teaching electrical circuits, because 2006 it is given, somewhere around 8 or 9 I have discussed this particular problem in my class earlier. So because the source impedance when V2, the load is connected, the two-port network parameters have been considered with load being not connected. But this can be solved easily like this also, because V2 is common here. So it is not the V2 is open circuit voltage here, it is the load voltage. Okay, that is how you have to treat it appropriately. Okay, so direct substitution of the corresponding quantity V2 equal to minus I2 by RL is permitted. Okay, anyway, I hope it can be thought about it. So based on the problem, you have to think where you have to start and how to do it. That is the only point which I want to say. Okay. Then the third problem, some simple examples are collected for this. Okay. It's not that these are the only examples. For illustration only I have just mentioned. Each one has got specific this one. And so the ABCD matrix for a two-port network is given by V1, I1, ABCD, V2 minus I2. Okay. And the parameter B for the given two-port network is in ohms correct to 2 decimal points is. Okay. So I repeat the statement of the problem. Again, this matrix substitution need not be given, but anyway, let us see. The ABCD matrix for a two-port network is defined by V1, I1, ABCD, V2 minus I2. Given the circuit is V1, input voltage measurement and source excitation voltage, plus and minus, this is V2. I2 is into it, I1 is into the port 1, is into the port. So 2 ohms, 2 ohms, 2 ohms. It is a T network that is being given. That is this is Z1, Z2 and Z3. Right? So I will tell you the solution to this. If you have got idea already in your mind, you can tell the answer straight away. I will give a pause for a few seconds while explaining this particular circuit once again. Question. In the meantime, you can think about the answer. Even if instead of doing like this, do you have an alternative solution? By looking at the network etc., can you do it? If you are thorough with the topic, then you can say that. Let me answer that another way also, but I have given here a systematic method for solving the problem. But if you are confident, you should not waste your time. Okay? But anyway, let me repeat the question. The ABCD matrix for a two-port network is defined by V1, I1, A, B, C, D, V2 minus I2. And the corresponding circuit is V1 is of course the driving point voltage at port 1, V2 is to be measured, and I1 into the port 1, this is I2 into the port 2. This is question that is been given already. So 2 ohms, 2 ohms and 5 ohms, it's T network. The parameter B for the matrix for for the given two-port network is in ohms correct to 2 decimal points is. Have you got the idea? So it is 4.8 ohms without doing this particular exercise. How? Convert this star into delta and the impedance connected between the common points. That means you convert this T into pi, say. That is equivalent to T network and pi networks of the transmit network. So that is 2 plus 2 plus 2 into 2 by 5. That is converting delta star into delta R1 or Z1 plus Z2 plus Z1 Z2 by Z3. So 2 plus 2 plus 2 into 2 by 5 is 0.8. So 4.8. That is the answer. Is it right or not? How we got that? Because the transfer impedance is the one connected between the two ports, right? So therefore, whether you will get the corresponding solution because it is common between this one, you get that as a transfer impedance. Then of course, then there is a definite relation between the corresponding quantities. Transfer impedance is there. I am talking about transfer impedance is there in relation between them. Yes, that is what I mean to say about the interrelationship between the quantities. Because for the same network, we can classify the 6 types of parameters. Okay, in different contexts, different applications will be there. That is the only thing. So anyway, I am not going to discuss in that particular aspect, but so by looking at the network itself, the transfer impedance is equal to the common between the port terminals, which is not being shown. This is conventionally being solved. Later, while explaining, I got the idea stating that this 4.8 also satisfies with this. That is, you convert this into pi network. That is having delta connected one with a common between the ports 1 and 2. So it is a transfer impedance. It is common between the two terminals when V2 is equal to 0. Right. So that will be same as, because when the other end is shorted, naturally when the other end is shorted, when this is converted to delta, this is a common portion and current flows through that only. So V1 by minus I2 you will get. So that is how you can think about it. So 2 plus 2 plus 2 into 2 by 5 is equal to 4.8. So now that is a clue for fast solving the problem if you really identify that particular one. Now without understanding that or without having that clue, you follow systematically. So what I mean to say is, for making practice sessions, you have to solve like this, methodologically, right? Systematically. But you have got thorough idea in your mind and you already tried similar type of problems, identifying this type of problem, then straight away you can go to the answer stating that yes, the transfer impedance is same as the B. So therefore, the corresponding convert this T into pi network, that is the equivalent star to delta conversion of one of the elements which is connected, would have been connected between the two ports, is the answer. The value of that is the answer. So that way you can make a not a guess if you are thorough with that. Anyway, now let me try to do this. So V1 is equal to A into V2 plus B into minus I2. So in that, therefore B must be equal to V1 by minus I2. That means V1 is port 1 is excited at this port. That is the meaning of the ABCD parameters. And port 2 is short circuited. When V2 is equal to 0 implies the port 2 is short circuited. Find the current flowing through that. So that is, this is I2, no doubt. So minus I2 means port 2 dash current. That is going through the short circuit current, right? So therefore, now the R equivalent is, because the voltage source is in this side, now we will find the total current, the current division rule and other things. So 2 into 5 by 2 plus 5 plus 2 is 10 by 7 plus 2 is 14, so 24 by 7 ohms. Therefore, I1 will be equal to V1 by 24 by 7 is 7 V1 by 24 amps from 1 to this terminal. So I1 is the direction that is being given. Now minus I2, that is current flowing through the short circuit at the port 2 dash is equal to I1 into, now this becomes the opposite resistance divided by this. So 5 plus 2. So that is 5 by 5 plus 2 into 7 V1 by 24. So that is I1 into 5 by 5 plus 2, because this becomes the opposite branch, this becomes the parallel branches because it is, this end is shorted, V2 equal to 0. So this is conventional way of solving. So therefore 7 V1 by 24 into 5 by 7 is 5 V1 by 24. Therefore B by minus B equal to V1 by minus I2. B is equal to V1 by minus I2. That is this value has been obtained as V1 is expressed. So V1 by minus I2 is 5 V1 by 24. V1 getting cancelled. The 24 comes in numerator. So 24 by 5 is 4.8 ohms. So same thing I have mentioned. If you have got a fraction of second confidence on this, it is equivalent to a common fourth impedance. So therefore, it is equal to 2 plus 2 plus 2 into 2 by 5. The converting star into delta, that value is same as this without calculating using this particular one. That means you need to calculate systematically. But a clue to this, if you are confident, you can answer this also by matching. Because it is objective question, that is fill in the blanks, not multiple choice question. No lottery can be made in this. If you are thoroughly, you can answer this. Okay. I hope you got my point. Okay. So these are small but simple problems that have been taken for illustration, and this is the most typical problem. So I just quickly brush up in 1 minute or 2 minutes the transient parameters. So that I will go to the hybrid parameters, and so V1, I1 are expressed in terms of V2, I2. So this already you are aware, you might have studied not only in circuit theory, you have done in power system applications also for finding the ABCD parameters of short lines and medium lines, long lines, comparing the corresponding quotients. Always AD minus BC has to be satisfying equal to 1. So all these things, and for particularly for medium and long lines, you have to use T or pi network, and then for short lines, there is no need. So and that is all. You can application of these transient parameters in electrical circuits that have been studied as two-port networks. So I have got some more points to mention which I have not written here. Is that which I most of the times I got passion towards telling is that now I will ask one question orally. What is the transmission network? Whether it is symmetrical, whether it is reciprocal only, whether it is not symmetrical, and it's symmetrical as well as the reciprocal network. So in general, I repeat, a transmission network is whether it's only reciprocal network, only the symmetric network, symmetric and reciprocal network, okay, etc. So the transmission network is essentially a two-port network, okay, and AD minus BC equal to 1 if satisfied, it has to satisfy, then only it is called reciprocal network. That is one thing. Now, the other point which I have to state that it will be symmetrical as well as reciprocal. That means a reciprocal network will also be equal to symmetric network if A equal to D in this case. If A equal to, the voltage ratio is same as the current ratio. How and all you can see from the examples, that is only. So if AVD A equal to D, then that is out of scope because I have mentioned the power system network. Okay, so because I drawn that subject earlier, so therefore I know the analogy between this fundamental circuit concept of two-port networks and the transmission network analogy also. So that is the importance of that. So if A equal to D only depends on the parameters of the corresponding coefficients. Okay. You know, for long lines or medium lines, the values of the A, B, C, D also can be computed based on the corresponding T network or pi network. So this is beyond scope to discuss at this point. That is only just application what I have mentioned. So now this is a typical problem with respect to the transformer that is being given. So comparing the corresponding A, B, C, D, you get A equal to N, D equal to X in this particular problem. Therefore, because the problems are not unique, therefore, whatever the strategy or observation that has been made is related to that particular problem only. So you cannot remember or mug up these things. Mugging up means by heart చేయడం కాదు, by heart చేస్తే రాదు దీంట్లో, కాన్సెప్ట్ అర్థం చేసుకోవాలంటే. Okay. So therefore X happen to be equal to 1 by N, that is being asked. Okay. And this is again typical problem. It is not the V2 is not the open circuit voltage, it is a load voltage that is being considered in this case because the terminated by RL means the load resistance is connected. If 4.2 is terminated by RL. So from this basic equation, you can find out the corresponding what is I2 also. So making I2 equal to 0, then you will have open circuit voltage here, V2 means. But when I2 equal to 0, you would have substituted, but I2 is not the corresponding the open circuit open circuited, it is connected with the load resistance. That means from this we can easily compute these things. Okay. And that is the advantage of the transient parameters. Without actually calculating these things, if you know the ABCD parameter and load resistance in the given network, whatever is the network configuration here. Why we are discussing all these points? Because There are ways to solve the problems. The network may be complex. You cannot go to measure the transmission network and then find the load resistance sending at one side, receiving at the other end. But you know the ABCD parameters. Then you can estimate the current at the load end. That is how you can think about the application of this one. Okay. So that is how you have to think the application of the corresponding transmission parameters. Otherwise, without knowing these things, now what is the advantage of this? I don't have to worry about what are the actual transmission parameters in the sense what are the ohmic value, what is the corresponding series impedance and shunt impedance of the T or pi network of the power system network, etc. What I know is only ABCD parameters of that, and I can still compute the load current or the source impedance that is being offered in the circuit. So that is how this particular application of the ABCD parameters is there. That's what I would like to emphasize. Okay, I think giving more points should not get confused. Okay, then this is also a typical problem, and finding just B is a transfer impedance, and ABCD matrix for a two-port network is defined by V1, I1, ABCD, and so this two-port network matrix is generally known because it is only equation that are given. For this network, this is given as T network. If you convert that into pi network, the transfer impedance can be obtained as the element connected between the ohmic value of the impedance that is connected between port 1 and port 2 only. Instead of that, you can do it using the corresponding conventional way of solving this particular problem, starting from fundamentals like this. Making V2 equal to 0, find the corresponding minus I2, and then take the V1 by minus I2 is the ratio you can get. But anyway, this is a typical answer to this particular one. And so you should be able to imagine that that value and this value will be same. So I would like to discuss next parameter. So sample examples only I am giving. And then hybrid parameters. So far we have discussed the impedance parameters, and ABCD parameters. So in one case, that is open circuit parameters, V1, V2 are expressed in terms of I1, I2. Short circuit parameters, I1, I2 are expressed in terms of the V1, V2. Now the third one, ABCD parameters, is source voltage and current. That is V1 and I1 are expressed in terms of the receiving end. V2 and I2 are minus I2. Then here V1 or I2, V1 and I2 are expressed in terms of V2 and I1 respectively, or I1 and V2, whatever it is. So V1 is equal to H11 into I1 plus H12 into V2. I2 equal to H21 into I1 plus H22 into V2. So these are called hybrid parameters. As I said, there is again definite relationship between the all types of parameters. You can refer to any textbook, you have to big column, a 6x6 matrix for getting the interrelationship. You don't have to by heart them, but you have to follow systematically from the transformation of these things. Okay. Anyway, H11 is equal to V1 by I1 when V2 equal to 0. So this is known as the input impedance with port 2 is shorted, output port is short circuited. Now you can see in the transmission parameters also you have got A is equal to, V1 by I1 is the source impedance that is being asked, is based on the load impedance that is being connected. Okay. So now this is a typical case with V1 by I1 is the source impedance when port 2 is short circuited. So conditions differ. So that is where there must be some clue in finding out these things one-to-one relationship. That is beyond scope here because time will not be sufficient to discuss that one. That is an independent topic. We need an extra maybe a 2 hour slot for that, for getting the or maybe more, because all two-port network parameters one-to-one this one can always be obtained. Okay. Anyway, H12 is equal to, because this is the last one which I would discuss, inverse and inverse transmission parameters and inverse hybrid parameters. Generally, we are not used much. So therefore, even so far also nothing has been given overall in the gate examining as I observed. But anyway, not many complex problems and not complex problems are also there in this. So which are being available. So for illustration, but so far I did not see many times hybrid parameters are being asked in the gate examination for solving. But this is very important one, and that is inverse and hybrid, inverse transmission and inverse hybrid parameters are not being given. Hybrid parameters would have been asked in the gate examination. Sorry. So I will be skipping those two. That's what I want to say. After this, I will go to the next topic. After the explanation of this one with some simple example which I have considered, I will pause for 30 seconds or half minute. My friend Mr. Surendra will help me in making the presentation of the transient networks. So I will be presenting before that the hybrid parameters. After this 10-15 minutes, I will give a half minute break before we go to the transients. So break in the sense for making the PPT to be available to you on the screen. So here hybrid parameters is one type of the two-port parameter where V1 and I2 are expressed in terms of I1 and V2 or V2 I1. So V1 is equal to H11 into I1 plus H12 into V2. I2 is equal to H21 into I1 plus H22 into V2. So H11 will be equal to V1 by I1 when V2 equal to 0. So that means V1 is excitation. That is port 1 is excited, port 2 is short circuited. Okay. So even port 1 is excited and port 2 is short circuited, you can get the Y parameters also. But that is a different context. That means so therefore there is a relationship between certain quantities. That is how you can imagine, right? So H11 is equal to V1 by I1 when V2 equal to 0. But that is I1 by V1. Okay. So because in I1 is equal to Y11 into V1 plus Y12 into V2. I mean, don't get confused here, but I am telling because the ABCD parameters are there and the admittance parameters are also there here. So you can see Y11 is equal to I1 by V1 when V2 equal to 0. But here we have got a different relationship, right? So if I tell all everything, probably there is always possibility of getting confused. But already this subject is familiar to you, so I don't have to worry. So I hope we are getting more familiarization. So H1n is equal to V1 by 1, whereas that is I1 by V1, but terminal conditions are different. Please understand that. So Y11 is equal to I1 by V1. That is admittance. This is the impedance. So input impedance with the output port is short circuited. Okay. So terminal conditions and the parameters are different. So therefore, but there looks to be similar. That means there exists a different relationship. I want to emphasize on that particular one. Okay, although I am not going to discuss further. Which one I am leaving at what point only I am just cautioning you. So H1, because these only just some of the topics which I can cover in these 12 days, which are prime concern. So therefore, now H12 is equal to H12 is equal to V1 by H12 is equal to V1 by V2, H1 to V1 by V2 when I1 is equal to 0. So this one of the textbooks has given this as voltage, instead of voltage ratio, generally we call it as voltage ratio. That is called, the name given to that is reverse voltage ratio, because voltage ratios are always taken as V2 by V1 or second input side to output by input or otherwise. Okay. So therefore this is referred to as reverse voltage ratio, and sometimes it can be gain, reverse gain, because gain implies output by input. Okay, there is reverse gain. So do not worry about that. You treat that as only ratio, voltage ratio, which is the input port being open circuited. Okay, I1 is equal to 0. And similarly, with V2 is equal to 0, right? So yeah, H12 is equal to V1 by H12 is equal to V1 by V2. Yeah, that I mentioned. So sorry, I think this should be H21. That is where I'm getting confused. Sorry. So this should be H21. Please correct it. So H21 is equal to I2 by I1. So here I2 by I1. I2 is the source current, and so therefore I2 by I1 when V2 is 0. Then V2 is 0 means it is not the source current. V2 is short circuited. That means I1 is still the excitation one. So that is where we have to treat the parameters as such. So H21 is this, H21, sorry, please correct it. H21 is equal to I2 by I1 and V2 is equal to 0. Now, there is a typical one that here one point to be mentioned, always the sign convention. So I2 will be into the port by convention, but with respect to this, because I1 is excited and I am making the input current to be measured, it is the current will be from away from the port. So therefore I2 will be, the measurement of that will be away from the port 2 to 2, right? So that value will become negative always. So typically when H21 is equal to minus value and H12 equal to minus of H21, then it is a reciprocal network. So therefore, for a passive network, H21 will always be negative. These are the certain properties, okay, of the corresponding two-port networks with respect to the various types of parameters. So you have to understand the properties. That is a component, the way in which the corresponding calculations have been made based on the convention. Only current into the port is taken as positive. So here, sorry, there is a small error here. So it should be H21. H21 is equal to I2 by I1. So I2 means it is a, so that is why it is called the forward current gain with output port short circuited. That is, what is the forward current gain? When input is excited at port 1, I2 is the current at the load end. So I2 I1 is the ratio of the output current divided by this one. But output current by convention is taken as, here input port is taken as into the, but it is away from it, so you will get minus sign there. So that is the meaning of it. So H22 is equal to, next one is I2 by V2 when I1 equal to 0. So this is the output impedance when port 1 is open circuited, because I2 by V2 ratio gives you the impedance part. So it is also referred to as the when port 1 is open circuited, that means V2 is excited, that is in this case. So V2 is excited and I2 is the source current that is being measured. So H22 equal to output impedance at port 2, right? With port 1 is open circuited. Whereas if you look at it, the impedance parameters, just for comparison, you can see in this expression Y22 equal to I2 by V2 same, but V1 equal to 0. Now see the difference. Here Y22 equal to I2 by V2 is the source impedance at port 2 at V1 is equal to 0. Okay. Whereas the hybrid parameter is H22 is same output impedance but at port 2 only, with port 1 is open circuited. That makes the difference. So you have to choose appropriately for finding which one you are finding, and the corresponding relationship is always admissible between the corresponding ports. But they are not one and same. There is a different relationship between the quantities. Output impedance terminology may be same, but at port 2 also may be same. But one is on the port 1 is open circuited here for this one, whereas for Y22 V1 is 0, means short circuit. That is port 1 is short circuited. So one is the open circuit impedance, one is the short circuit impedance on the other side. And the output impedance is being computed. That is the meaning of this, right? So they are not one and same. All different 6 types of parameters are being there, right? So now I would like to give small examples of this one for computation. I hope I told many points, but sometimes it may be confusing. And while writing, we have not taken this minus sign, but I2 will always be negative. You will obtain this H21. That is why for a passive network, H21 will always be negative, as that has been stated. In this, H21 must be negative, H12 is positive, H21 must be equal to minus of H1, H12 is equal to minus of H21, and if such condition are satisfied, then it is a reciprocal network. That is a property of the two-port network with respect to the hybrid parameters. With the conventions of port 1 and port 2 are the at higher potential at 1 and 2, and port 1 and port 2 currents are taken as into the port is taken as positive. That is a convention, and there is the inference. Right. Now, as 2 small examples are there. After that, maybe after 10 to 12 minutes, I will go to the next. This one is transients. So a two-port network is shown in the figure. The parameter H21 for this network is given by. So you can see this has to be careful. Always the gate question papers are tricky with respect to the sign conventions. One has to carefully follow. Okay, a two-port network is shown in the figure. The parameter H21 for this network is given by minus half, plus half, minus 3 by 2, plus 3 by 2. So given this is I1, V1, V2, I2, same notation that is being given, and all are equal resistances. All are equal resistances. Now, by I have just rewritten this thing. By looking at the network, you can see. But anyway, V1 is equal to H11 into I1 plus H12 into V2, and I2 equal to H21 into I1 plus H22 into V2. So H21 is equal to I2 by I1 when V2 equal to 0. So when V2 equal to 0, do it by normal conventional procedure. So this is a short circuited one. So this current will be minus I2 by notation. So current is into the port is positive, but we are getting the current on the side because V1 is the imagined excitation source here, V1, that is implied at port 1 and 1 dash, this is port 2, 2 dash. So then the I1 is a current delivered by the or into the port, source current. So therefore, you can see I1 gets divided into 2 and the direction of the current is I2 should be into the port is taken as positive, but I2 will be minus of this one. So because this current. So therefore, I2 equal to minus I1 by 2 or minus I2 equal to I1 by 2. Therefore, I2 by 1 is equal to minus 1 by 2. Again, why you are taking minus sign? Always this is a question. Maybe 3 to 4 times a similar person has asked. I think same person may be asked what these sign conventions. I am showing this as the current flowing from 2 to 2 dash. But the actual direction of the current that is chosen originally is into the port is taken as positive. So therefore, this ratio will have to be negative. So its value equal to minus half. So that is where to make the standard conventions, whether you are following or not, both answers are given. It's not the magnitude only here, because these are the parameters related to the voltage and currents or measurement of these things or finding the current flowing through. So the algebraic nature of the corresponding directions also must be taken into consideration. That is very important. So therefore, A is equal to minus half and this is plus half. So similarly, next question is the H parameters of the circuit shown in the figure R to be computed. That is given as multiple choice question in GATE 2005 for 2 marks question. So this is 10 ohms. So here no resistance is being given. That is implied that its value is 0. Okay, that is implied that its value is 0. Okay, so what is all the H parameters are being asked. So conventional way you can do it. On looking at it, we may not be able to get it. So I will not read out these all 4 types. You calculate and then check which one is tallying. I hope if you are doing right, then you can easily verify that with what matrix it satisfies. Then you can put the corresponding solution appropriately. So we know V1 is equal to H11 into I1 plus H12 into V2, and I2 equal to H21 into I1 plus H22 into V2. So when V2 is equal to 0 and port 2 is short circuited, we want to find out the parameters of H11 and H12. That is first row elements here, either of the corresponding matrices. So H11 is equal to V1 by 1 and V2 equal to 0. V2 equal to 0, this is the source. So V1 by 1 is equal to, there is no problem. This is 0, but so this is shorted. Okay, because the resistance is 0 here, that is implied, and there is a direct short circuit between this. So directly V1 by 10, I1 is equal to V1 by 10. So V1 by 1 is 10. So that you have to understand that here the resistance value is shown to be 0. That need to be considered in the parameters because it is a T network that is being considered. So I am taking a cup of tea and explain the T network. Okay, for finding the hybrid parameters. So in this, the corresponding resistance is being given as implied that it is to be treated taken as 0. That is the meaning of this. So because of that, you will get a short circuit here. Otherwise, these two elements would have been parallel. Even if you make it parallel, 20 into 0 by 20 plus 0 is 0 because the multiplication is 0. So H11 is equal to V1 by 1 is 10, right? Then similarly, H21 is equal to I2 by I1. So because I2 is now away from the port, so and you can see this is started. I1 is equal to minus I2 actually here. I1 is equal to minus I2 because this is being shorted. Same resistance impedance is being there connected between 1 and 2, but I2 is into it. So therefore, I2 equal to minus I1, right? Then when second case, when port 1 is open circuited, that is V2 is being excited, you can keep this as V1 means it is measurement now. Okay, so I1 equal to 0. Okay, then when I1 is 0, that means this is open circuited. Find the ratio of the V1 by V2. Here you can see no current is flowing through when port 1 is open circuited. Sorry, when port 1 is 0. Yeah, when port 1 is open circuited, no current flows through the port 1 naturally. V2 is being excited and directly it is connected across it. and there is no current flowing through this, so this voltage V2 will be appearing across V1 also. So therefore V2 equal to V1, or V1 is same as the excited voltage V2. That is what the meaning of this. So that is where you have to carefully understand this and network classification. So H12 is equal to 1. Now you can see H21 is equal to -1, H12 is equal to 1. Then only it can satisfy. That means H21 is I2 by V1 when V2 is 0. Right? And H12 is equal to V1 by V2 and I1 is 0. This must be magnitude wise it is same, but it is a sign convention is different. That is the property of this particular hybrid parameters. How it can happen? Because of that properties and sign convention that have been followed. So both are different, but in magnitude they are same, but this is the ratio of the current, so it is minus of that. So H2 equal to H21 equal to I2 by 1 when V2 is 0 is -1. H12 is V1 by V2 is equal to I1 equal to 0 when I1 is 0. That means when port 1 is open circuited, the ratio of the voltages will be same as with the magnitude of that one with respect to the reciprocal network. With current ratios that have been chosen with V2 equal to 0. See how typical it is. So V1 by V2 is same as I2 by I1 with a minus sign. So that is, but the terminal conditions are different. You cannot equate them directly. Okay. So with respect to the parameters, the ratios, because it is ratio, we can equate them. So H21 is equal to -1, but therefore H12 is equal to minus of H21. So you can see clearly from this, the magnitude of that one is same with a minus sign because this is the current ratio with port 2 is short circuited. This is voltage ratio with port 1 is open circuit. Both are different parameters, but the ratios are same because the reciprocal network. Just as the ratio of the excitation to the response have been shown earlier, but the transfer and the corresponding to the ratio of the excitation to the response using reciprocity theorem, that is applicable. Here also it is typically for a reciprocal network, if you want to consider the corresponding nature of the measurements and nature of the corresponding source excitations, that is terminal conditions are also different here. So I2 by I1 when V2 is 0 is different from V1 by 2 when I1 is equal. These are called terminal conditions. These are, one is the source and the other one is the excitation response. So this is a typical way of knowing other than the parametric equations, not only from the parameters, equations or the parameters or hybrid parameter equations or any other thing, you have to understand the terminal conditions and see how they have been equal. That is why they are called reciprocal networks. If such a situation occurs, only it is called reciprocal networks. And for every reciprocal network which you treat, if the first condition of the reciprocity theorem is satisfied, it also satisfies. That is the property of this one. That is how you have to understand. Okay. Where are the proofs? This is a century-old year subject. Already proofs are being there, must have been there, and we are not interested in proofs here. We want only the outcomes. We want to know how to do it and other thing, because it's not only same derivations being asked. So understand the way in which the parameters have been obtained or what are the properties of the corresponding circuit configurations. That is what we have to think in terms of these things. Okay, I think that's all the brief representation of the two-port networks. Now I request our friend Mr. Surendra to change over to the transients. Okay. Yeah. So, so far I have discussed various types of the two-port network parameters, and there is another one which I am not discussing. That is under two-port networks, there are two classifications that can be made. One is called interrelationship between the parameter values. As I mentioned, one parameter can be represented in terms of the other parameters. The other one which I am not discussing is the transform network parameters. That is in the impedance parameters in terms of the Laplace transform operators. But that is absolute necessary in terms of the Laplace transforms in terms of the transient networks. So a brief introduction of the transform network parameters will be mentioned here. Otherwise, computation of the transform network parameters and the interrelation between them is a separate topic by itself. Is extension of the original two-port network parameters topic. So which I am not going to discuss. I am skipping that because hardly I have got 3 more days. And so today and probably may be extended to tomorrow also, because I have got only 1 hour slot here. I may be able to discuss some DC transients and if possible complete that, but it will not be possible because good number of examples, umpteen number of examples are there in DC transients alone. In that book we have got nearly 37 examples are there, which I have collected a few, 5 to 6 in each case, or a good number where you can understand easily and try to get it. Some of them are for electronic circuits or electronic students only, because we are not going to study some of the topics like attenuators, equalizers, and other things. So it's a very good solutions are being given, which for your confidence you can verify them using that particular book. Maybe if you got your counterparts with ECE friends, you can make use of the book that you could have been purchased by them, because except for that topic, majority of them are only for electronics engineers. But electrical circuits is common subject definitely, so therefore I am referring to that. I am not canvassing for that textbook, but I found that to be easy for illustration, and I am making use of that. If the questions are not available but related to our topic, then only I am going for another book, or I on my own I am presenting. That's why I am telling, because generally we don't say some book is good or some book is bad. We should not recommend like that for these things. But I found that useful for me, okay, for making preparation of this one. So transients. I only just classified here. So I would like to start the topic transients. Uh, so before that, I would like to cover, there are what are the topics to be left out so far in the remaining 3 days: transients, DC transient, AC transients, and three-phase networks, three-phase circuits rather, and filters. Filters, of course, majority of the students, I do not know how many you might have studied or not. Even I have studied only about a decade ago. Doesn't matter. I can do that, but time will not be definitely sufficient. I may have to skip that for this 12 days slot. Okay, because transient might take today half portion, and the remaining DC transients and AC transients also there. I don't think tomorrow also I may be able to complete, or if possible I will try to complete. Otherwise we have got the three-phase networks, and I have got one idea in my mind. Our friend has helped me in making the gate question paper of 2020 being solved. Let me also verify that, and I will give you tomorrow the questions being written, and I will project that for you this one. You do that by day of tomorrow or last day, so that we will solve last 1 hour. I will try to give you explanation to those 4 problems covering the entire syllabus. Okay, so gate 2021 set I got, and I have given the problems for these things to our colleague Mr. Hussein Wali. He has making it, and he has sent it to me also. He has made it, and I will do that only for the, because it is gate coaching. So I want to, because gate 2020 solutions are not being available, let us compare our solutions with the to be published one. Maybe before your gate exam, they will be definitely publishing. You can see one of the books is published in January only, December or January. So because the gate exam results, after the results are announced, the people will start preparing. In the pandemic situation, maybe they might have got time, but they don't have time to publish. So everyone will start revising the gate these things. That is usually people you do it. People they do it, right? So anyway, and one more thing is that there will be a problem for you now after this one. You have to appear for the first examinations, or third 3-2 examinations. I mean 4-2 examinations. Somebody may be getting a job. Some students already might have got a gate score also, good score, and the next persons who did not get a gate score only might write. But gate is very important even now for most, not only for competitive examinations or getting a job, even for teaching profession it is becoming mandatory nowadays. Even for assistant professor recruitment, gate is a must. They are exempted. If gate valid score is there at the time of this one, after PG being obtained, postgraduate degree is being obtained. If you do even gate after that, it is become mandatory. Then the recruitment process, they have considered gate score, and you don't have to appear for the entrance examination along with others. Statewide entrance exam need not be done for the appropriate gate score. If you have got for the appropriate years, that will be maintained. So why I'm telling is that that is why do not worry about the only gate. Engineering services, UPSC, Union Public Service Commission, APPSC examinations, all these things. You need these basic core subjects to be remembered always. You have to keep them in brushing up your mind. It's not the end. Once the coursework is over, it's not the end of it. As a professional student, you should have these things in fingertips, particularly mathematical subjects and basic concepts and subjects on core and elective subjects and interdisciplinary subjects, all those things. Wherever you got interest in our this one. Try to brush up, try to keep the your subject content in active memory. Okay, so do not relax till you are assigned with some job or some work. You have to keep your academics, but if you want to take anyway teaching profession, you have to be active in academics. There's no other choice in that. Okay, anyway, that's what we did ultimately. Anyway, so just it is only a stopgap discussion always I make before a changeover of the topic is there, because this is a different topic altogether. You might have studied the basics, but I will define what is a transient. Transient means sudden application. How the circuit element will behave. What is the characteristic response of the current, or the how do you obtain the voltage? A brief discussion of this is being done in the first day itself. That is how the inductance acts, how the capacitance acts at the time of switching under initial conditions, under steady state condition. Here, not only those things will be used, but also we are interested in writing down the expression for at any instant of time. It's not enough you say open circuit or short circuit conditions, initial conditions, under steady state condition. Suppose you are interested in finding out the current at any instant of time, time t equal to 1 second, 2 seconds, or as time tends to infinity. What are the and the problems are very trivial in this case, in the sense very typical. You have to consider the initial conditions. What is in my initial conditions? Now people talk about how inductance stores the energy. It is not storing. It is the time constant of the inductance which makes the inductance energy. Even you might have observed a transistor. A transistor, those days when you don't have common subjects and other things, or without this one, we used to observe. You go to the near the tower, okay, electric tower. You switch on the transistor, and then you will have the amplifying will be there. And second aspect of it is, suppose the transistor is switched off. A few fraction of seconds, okay, even radio or transistors, when we were students, we used to observe that when transistor is cut off, then still that sounding voice will be there, voice will be there. That is, it takes some time constant to die down. So even though supply is cut off to the transistor and the power is switched off, still that the voice will be there. The amplifying signal is continued to be obtained. So and the interference will be there between the electromagnetic noise and the corresponding mobiles also now. Okay, electromagnetic radiation. So those things are to be taken care. So transient phenomena is a sudden application of the voltage or currents into the network. What is the behavior of the circuit? So that for that you need to understand that. And not only, there are two types of solutions in this. That is two types of networks. First, DC transients and AC transients. Today and some part of the tomorrow I would like to discuss DC transients, and subsequently AC transients I would like to discuss, the toughest topic. Okay, and but it has got applications because DC offset currents will be there. Briefly I will mention those things in AC transients. I would like to discuss elaborately DC transients to the extent possible, because lot many problems are there, highly involved problems are there, very tricky issues are there to understand, and it's not that easy to understand. It takes a lot of time to understand, study till you confirm that yes, you are thorough with that. Otherwise, DC transients is one of the confusing subjects. It's not tough subject, tough topic, tough chapter కాదు, కానీ lot of simple points will be there where you have to understand carefully, right? Anyway, if you are very thorough with the fundamentals, the subject will be very easy. But that is where sometimes it is always confusing with respect to the science, with respect to charging and discharging of the capacitor voltages or inductance voltages, how they are being represented. And so that is about DC and AC transient, sudden application of the voltage sources into the circuits, and the component behavior is one aspect. The initial current or initial voltage across the inductance or capacitors, or steady state current and voltage across the inductance or capacitor. Not only that, at any instant of time we want to find out the expressions, and thereby compute at the end of at any time instant of time t equal to 1 second or 2 seconds, or at the end of time tending to infinity, to find the steady state value. And it is important to note, I have got one typical example. When a capacitor is being charged, it charges instantaneously, because in that circuit resistance is not being given. Already a charger voltage is being connected to that. Let me see if we can cover those things subsequently in today and tomorrow's proceedings. Then some of the doubts can be cleared, because I told one of the questions that is being asked, how inductance is stored electromagnetic energy. It is not that exactly it is storing. Till the fraction of a moment at least, even though the supply voltage is being cut off, still if there is an alternate path, current is delivered to that particular one. That is how the the corresponding the voltage that is developed in the inductor due to the rate of change of current is going to be used for the different circuit. That is called the storing of the energy in that context. It's not that you are capturing the energy. Storing means you are capturing and putting at some point. That is not visualized. Okay, so do not think in terms of storing of that in that sense, right? So energy stored means for a moment or for a certain time, the energy that can be obtained in the inductance or capacity is being utilized when there is a switchover after the steady state condition has been achieved in that particular component. That is possible. Those things we will study in this particular one. But now I have started considering for series circuits and parallel circuits may not be discussed, but still it is vital. But some of the examples are there. No need to remember those equations, but it will be enough if you solve RL series circuit, RC series circuit, RLC series circuit. I would like to mention with respect to RL series circuit in today's this one, that will be good number of examples. I found nearly 5 to 6 examples are there. So seem to be, if you follow them, it's okay. Otherwise, they are the complex ones. People will be always worried about even teaching the subjects of transient, chapter of transients in the electrical circuits. Okay. Okay. Although it is given as the first topic in the syllabus content itself, along with the KCL, KVL, we always push this because we know the our own difficulties in making these things. In the first level itself, it is difficult, but unless you know the component behavior, we cannot understand the other things. But anyway, we take it as granted. Now we will go to the actual detail. Now there are series circuits and parallel circuits and any other combination that can be made. And this is transient DC transients. And there are two types of solutions. One is time domain solution using classical equation, differential equation solution. And the other one is the Laplace transform approach. So we assume that you are familiar with Laplace transforms. Even I used to teach before the mathematics people teach the mathematics, the Laplace transform solutions, reviewing them. And because we have to use them subsequently. And this is the concept called, I hope you are aware in transform network parameters also. You can find instead of open circuit impedance parameters, etc., that is Z11, you can say Z11 of S, that is transform parameters, because you want to analyze the frequency spectrum of the corresponding parameters, you have to necessarily use this. So there are two types of solutions, time domain solution and frequency domain solutions. Most of the times we are interested in frequency domain solutions using Laplace transform. But anyway, differential equation approach using time domain solution is referred to as classical method by mathematics people. So therefore, we are using still the same convention. Those days it is being classified as a classical solution, but nevertheless it is a differential equation solution only. Okay, that is the name given to that, classical solution. And the Laplace transform solutions are transform solutions, transform networks. And the solution of finding the current is being obtained using the transformed network parameters, formulate the transformed equation, and then making the inverse Laplace transform to get that. So we assume the background of this one. So that is why it is like introduction for the transient, and I will give this formula. I hope you are aware of this one, but anyway, I will explain these things. And then if you are happy with this one, then we'll start with the RL series circuits only, explain briefly, and then go to the solved example, because otherwise I hope these things you are familiar, but anyway, I need to explain. Everything is, that is why I mentioned that today I will start DC transients after the two-port network parameters, ABCD and hybrid parameters I will be mentioning. Okay, so this is the introduction to the transient topic chapter. So transients essentially indicates the transient behavior, means while sudden application of the voltage is being given, what is the circuit behavior of the corresponding components. Okay, circuit behavior of the corresponding components. So we have got series circuit, parallel circuits, or any other circuits in when applied to DC. And the solutions, the types of sources can be DC and AC generally. Okay, and any other components also can be taken, but you know, any other nonlinear or linear wave shape of the sources can be represented in terms of the sine and cosine terms. That is beyond the scope, but anyway, just this itself is very involved for understanding, so we will not go into the details of those things. And RL series circuit, RC series circuit, RLC series circuit, and parallel circuits also can be had. Similarly, AC transients with the sinusoidal wave shape, that also will study to a certain extent, because AC transients also is very important. particularly for electrical engineers. So we need to, whether gate exam sufficient solved problems are available or not. I would like to give some, at least some simple problems for our understanding. So, but not only I don't derive the equation, but I will give these things because this being almost the last chapter in second semester, whenever you are studying, people might not have find time to go through these things thoroughly. So therefore, now I would like to discuss these things because my approach, I am more confident and more having passion towards explaining towards the transformed network parameters concepts. So the network elements will be transformed, and the transformed equations with respect to impedance and impedance function I will mention here. Okay. So and that is I do not use the time domain solutions for these things. I give the Laplace transform solutions, writing down the Laplace transform equation, which is convenient to use. The only difference between I have to tell, because using the differential equivalent approach and the Laplace transform approach, is that the advantage of Laplace transform is twofold as compared to the differential equation approach. The first approach is, in the differential equation approach, you have got the solution being obtained for the integral differential equation of the first order or second order linear homogeneous equation with respect to RL or RC, RLC parameters. Find out the solution, find the constants of the corresponding quotients. You know, particularly K1, K2 for the integral differential equations or solutions that have been obtained using integrating factor or direct solution. There are so many methods in that. Okay, so that is a classical method using for solving the linear first order or second order homogeneous differential equations. We are not going to into that. That is also a part of the solutions. The other type of the solution is, the advantages of the Laplace transform is that, as compared to the differential equation, just now I mentioned, the initial conditions, based on the initial conditions, you have to find the quotients. Here, we will include the initial conditions and understand the circuit behavior, because in the switching transient there is more advantages. Okay, not that I do not know whether differential equation can be solved using that one or not. That is out of scope for us. But the method of approach is that the differential equation solution is being obtained, find the quotients of the corresponding one, introducing the corresponding quotients, the terminal conditions or initial conditions, and then try to solve the problem. But in the network solutions, we incorporate the initial conditions or steady state conditions here, obtain the corresponding expression for the current under transient behavior of the circuit elements. Right? So that is why this is powerful. That is one aspect of it. Second one is that we want to get the frequency spectrum. There is frequency domain analysis can be made. As I just mentioned categorically yesterday, S is equal to sigma plus j omega implies real component of the frequency component is generally taken as 0, but S is a complex quantity which a Laplace operator is being taken, but we confine that to j omega only. So therefore, the resistance is no change in that, it offers the same ohmic value, and G will be, the admittance parameter is conductance is G is 1 by R only. Whereas L gets transformed to the inductive reactance is j omega L, therefore j omega is replaced with S. How? That is a property of the Laplace transforms with respect to the complex quantities that you might be aware. Otherwise, take it as granted at this moment. Okay? This is not the stage to understand about the proofs. You have to understand the concept. These are well-defined theories and proofs, right? So, and reciprocal of this is the inductive susceptance will be offered is 1 by Ls. So directly like that. So reciprocal of this only. L gets transformed to Ls and L gets transformed to 1 by Ls, where S is the Laplace transform operator, which is analogous to the complex quantity j omega, right? So C is equal to 1 over Cs, and in this, and the reciprocal of this one is Cs. Right? That is how you can take this as transformed network elements of Z and Y. So the transformed network branches of the elements in the circuit, not the branches meant the coterary or spanning tree branches, the elements, okay, in series circuit rather. RL series circuit, so R is changed to R, so L gets transformed to Ls, so R plus Ls. Reciprocal of that is admittance function. So then similarly, these are being given in most of the books, and even get J.B. Gupta or Harish C. Raj given few thousands of object type questions, for electrical engineering. But those need to be solved. I am lucky to get the solved textbook, solved problems textbook by the electronics engineering textbook. That is made-easy publication. That is where the difference is. Otherwise, you have to solve them, find the object type questions solutions to be matched. Only the answers are being given, solutions are not being given. So you need to find time to find the solutions to that. Definitely, we can do it, but only thing is we need more time for doing these things. I'm lucky, as I said, in this pandemic situation, I'm lucky to get the solved question papers problems in electrical circuits to some chapters. I could not find for three-phase circuits anyway. Rest of the topics I could get, but some of them are uh, only gate problem solved. Okay, gate solved problems of 1 mark or 2 questions, 2 marks questions in various topics. Okay. Anyway, that is out of scope. Just because I have to give the source material. I am not hiding anything in this because it is only for the purpose of explanation. And so this is R plus in RC series circuit. This is R, and this R is replaced with R only in the transform network also in the impedance or conductance. What will be reciprocal of the combination? Now C is 1 over Cs. You can see that is inductive susceptance. Sorry, this is capacitance. So capacitive susceptance is 1 over Cs. So there is no need of plus G or minus G here. So just transform it by S. S indicates J omega, right? But Laplace transforms only, always we deal with the Laplace transforms. S operator. Laplace operator is S. And LC combination, L gets transformed to LS in the impedance type, and C gets transformed to 1 over Cs. Again, there is no resistance that is being shown here. So LCS square plus 1 divided by S. So you can see when L and C elements are being present, the characteristic equation will become second order, right? So that is where the corresponding problem is. With R and L elements only, these first order homogeneous equations only will get. And second order, L and C elements are being present, it will give second order. And RLC, you can see R plus LS plus 1 over CS. So LCS square plus RCS plus 1. If you take the R is the same. L gets transformed to LS, C gets transformed to 1 over CS. Take the LCM as CS in the denominator. So RCS plus LCS square and plus 1 is the corresponding impedance function. Reciprocal of this is the impedance function. Simple reciprocal. Now you can see some more examples for parallel circuits. Yeah. So for parallel circuit, R and L are in parallel. So R into LS by R plus LS. So L gets transformed to LS, already mentioned. So this is equal to R into LS by R plus LS, and that is RL into S by R plus LS only. Reciprocal of that is the impedance function. So R into C, similarly, R into 1 over CS by R plus 1 over CS, taking the LCM as CS here in the denominator. This becomes, and CS getting cancelled, R by RCS plus 1. So reciprocal of this is RCS plus 1 by R for impedance function. And L and C, you can see L into S by 1 over CS divided by LS plus 1 over CS. So taking the LCM as CS, C and getting cancelled both numerator and denominator. So LS retains LS by LCS square plus 1. And this is reciprocal of this, 1 plus LCS square by LS. And RLC combination, R into LS, L gets transformed to LS, C gets transformed to 1 over CS. So R into LS plus LS into 1 over CS by 1 over CS into R. So this is RLS into RL into S, product of the three, RL into S divided by CS getting cancelled. CS is taking LCM here. You get this one as S square into RLC plus S into L plus R. You will get. So this is the reciprocal of that. So now this is the typical one. I have mentioned that in Laplace transform solutions, initial conditions are going to be considered. The equivalent circuit in the corresponding one, not related to the impedance function or otherwise. In the making the equivalent circuit representation. Now this is the next one. Okay. So these are the various corresponding network configurations with respect to the RLC element values. Okay. And yeah, somebody asked if the resistance is 0, how it makes. Okay. So that is why you go for low frequency and milliamperes of current limiting these things will be put for the element, because no ideal inductor will be there. Somebody asked, suppose only why not you give the supply to the pure inductance or pure capacitive circuit, because of the reason I have explained already. But this is the corresponding transient analysis, you cannot avoid them, but the current has to be limited. That is why electronic circuits, they take low voltages and milliamperes of currents or otherwise. And we have to deal with high voltages also. Okay. So in circuit theoretical point of view, definitely the current has to be limited. And LC components only, if you take, they become oscillator circuits or tuned circuits, etc. most of the times. Okay. And the power consumed, average power in the resistive circuit will be 0, but it will be oscillatory circuit. So similarly, equal to resonant circuits concepts can be obtained using this one on the terminating conditions. So anyway, so part of this you will see the applications and filters also, right? So anyway, now this is the transform. The basic concept here is only R is unchanged with respect to the transform network parameters. That is V of S is equal to R into I of S only. L gets transformed to Ls, so that is V of S will be equal to Ls into Is. That is the meaning of it across the inductance. If it is V of S is the voltage across the inductance. So similarly, Vc of S is equal to 1 over Cs into I of S. So that is how the corresponding capacitance are getting transformed. Okay. So 1 over Cs is the impedance offered by the capacitance for the transform network parameters. So similarly, these are the corresponding reciprocals. So these are the combinations have been obtained. Only these three basic fundamentals, right? Now, these combinations are being based on those fundamentals. But now, the initial conditions are very important. Now, let us see what is the initial condition. Let us suppose that there is an inductor that is being present in the network, whose element is only shown here, just for representation. And suppose there is an initial current when the supply is being switched on to this inductor. Imagine that. Then the current flowing through the inductor is being there under steady state condition as the short circuit, because under steady state in the initial condition it acts as an open circuit, no doubt about that. So under steady state condition, current flowing through that, and that is that steady state current is going to be treated as when switch is being transformed to the other case. That is why the transients are referred as switching transients. That is, the transient is the case, the steady state current that is available for the moment. Now we want to take up the supply. How much time it takes for the die down, or how much is the time the current is flowing through the circuit and other things. So that is why the how much time it takes to die down implies that the energy is being retained in that particular storage element of the inductance for a fraction of seconds or milliseconds or microseconds sometimes. Okay, depends on the nature. So therefore, that is the meaning of the energy storage in this particular context. Okay, so the equivalent network corresponding to the replacement of this one with initial condition after the switch is being closed with the steady state current of I of 0 minus. You see, the switching has got the three components here. This is very, very important in that context. I have to explain this. Perhaps 0 is originated by Indians. Okay. In electrical circuits, we always use 3 zeros. Okay. Prior to the instant of switching, what is the initial current? Just at the time of switching, that is just immediately close at time t equal to 0, 0 plus is what is called the initial after the steady state is being obtained, or when the time at the time of switching, just immediately after that is called 0 plus. Earlier initial conditions up to mana. So just at the time of switching, right? Just immediately after switching, and at the time of switching. So before switching, at the time of switching, just immediately after switching, 3 zeros. So electrical circuit transient understanding the concepts before we need to understand what are the 3 zeros that are being considered in these conditions. Okay, so it's very interesting, typical, but sometimes the concepts are very important and they are difficult to understand, but the subject is not difficult. But if you really follow the corresponding notation and sign conventions and charging and discharges or inductor currents and other things, so you can see the equivalent circuit and the polarities. So the transform network will have LS into IS is same. That means imagine the IL of T is transformed to IL of S. Then the current will be this has got nothing to do with the impedance table. This is a different topic, slightly extension topic, salient points. Okay, so is minus L into I0 minus. So that means this is IS into LS is the voltage drop in the direction of the current. But this voltage drop will be opposing the flow of the current here of the inductance voltage. That is why. That means so when the supply, the initial current flowing through this is I0 minus, when this is being switched on, this can be going to the other circuit part, if at all that is being considered. That you will see. So the polarities of this one in the branch will be IS into LS, and suppose IS need not be considered. Then after this, the short circuit current will be flowing through. Then L into I0 minus is going to be the corresponding voltage that is going to be obtained, making this as a short circuit. Right. So this is the equivalent circuit concept using the transform network parameters. If this is the initial condition, So in the direction of the current, this potential drop will be opposing this particular one, because the potential drop is plus and minus here. So that is where a lot of concepts are being, some more concepts are being introduced. No doubt, in the first instance, it may be confusing, but definitely it's not the first instance. And you are in mature level of third and fourth year. Already some people might have written the gate exam and also the first attempt. Doesn't matter. You can attempt once again. And so anyway, so this is the initial charge across the capacitor. That is due to the charge, there will be voltage across the capacitance. So that capacitance voltage will be represented like this. IS by CS is the 1 by CS is the impedance here. So, and because C gets transformed to 1 over CS, 1 over omega C is the reactance, right? S is equal to, so 1 over J omega C, J omega. So IS by CS plus VC0 minus by S, right? So therefore you have to consider this particular one. So now I hope they are able to follow this, but nevertheless this is the consolidation of various new slightly different approach of the transient circuits, which is definitely is a different proposition of the conventional to this one. So far whatever we have studied is generally with respect to the steady state analysis. Now we will consider the transient behavior of the corresponding circuit component or circuits. So this one is again typical. I would like to briefly mention this. If the current flowing through this having initial current, this current will be opposing in such that the circuit is redrawn with respect to IS into LS minus L into I0 minus. This voltage due to the inductance current, the current stored by the inductor through the due to the rate of change of that one, which is steady state current under short circuit conditions. That is steady state condition, it acts as a short circuit or DC excitation only. I am talking only about the DC excitation only. Okay. So DC excitation only, right? So therefore, this is the equivalent circuit correspondingly. You can see the IS into LS is this, and this is minus L into I0 minus. So you can see the corresponding notation between the pair of terminals here. Because if you consider plus and minus here, it opposes this. So because this is plus, this is minus, because in the direction of the current, if you take the corresponding flow, this becomes the voltage source. Like I0 minus is the current flowing through that, is the steady state current prior to the instant of switching. You have to imagine like that, which will incorporate subsequently. And L into I0 mechanism becomes the voltage source. Okay. So that is, it is linear, because V equal to L dA by dt. dA by dt is I0 minus by the corresponding component. It becomes, that is the theory behind it. Let us not worry about that. So L into I0 minus. So similarly, the voltage, this is IS by CS plus VC0 minus by S. So this is again opposing this, but it will be, this will be in series with this, the current that is taken between the terminals, because IS in always in the direction of the current there will be a potential drop. So plus and minus here, so plus and minus. So therefore this voltages will be aiding with respect to each other, whereas this voltage across the inductance will be opposing with respect to each other. So the voltage that would have been present, okay, due to the change in the current or the steady state current is this, but whereas this is being generated due to the current source on current only, because 1 by C integral IDT, so it is in the same direction. That way you can remember this. And this is due to the current that is being obtained, not due to the, so I mean, so rate of change of current. So L into I0 minus, whereas this is integration of the corresponding current, which is the steady state current, and due to the steady state value, and the corresponding charge. Q equal to integral of that is becomes charge. Charge divided by capacitance is the capacitor voltage that you know. That is why. Okay. So integration of the current is equal to charge. Charge divided by the corresponding capacitance will give the VCS. Right. So that is how you have to treat this for the equivalent circuit. Now let me start explaining. I don't know whether I can do all the problems I got. I hope whatever the problems that are going to be considered, I will do it. And any questions you want to ask, it is up to the prayer, this one. And because RL series circuit, RC series circuit, RLC series circuit, I got nearly more than 12 problems are there. So today I may be able to do 2 or 3 problems in the remaining 30 minutes to go. So time will not be sufficient to solve. So RL series circuit, RC series circuit, good number of problems are there. And RLC also about 2 or 3 identified problems are there, which I will present in tomorrow's topic. So maybe DC transients again will take one more day for that. And next is AC transients I will discuss subsequent day. And 3-phase circuits briefly, and I will give the gate 2020, because we are left with only 3 more days. So Next is DC transients. I only introduced here, and I will briefly discuss DC transients also, RL series circuit. If I can solve all the problems, it's okay, but I am not in a hurry. It takes some time to understand. So, because good concepts are being introduced, and the typical gate problems are only I am solving because they are available for illustration. And next, tomorrow I will discuss together with some problems in RL series circuit. I will go for RC and RLC series circuit, and if till time permits, I will go for the AC transients. I would like to discuss AC transients. Whether it is given in the gate exam or not, for objective questions, definitely it will be useful. If not, for the type of problems which are solved like this using conventional type and 1 or 2 marks questions. Okay, and slightly involved in that. So AC transients is relatively tougher than DC transients. But anyway, I would like to briefly discuss about that also in one of the topics. And the third lecture, the last lecture will be three-phase circuits or three-phase circuits and AC transients if I can cover in one day. Then I will introduce three-phase circuits and problem solving for about 1 hour and 1 hour for discussion on the gate question paper. 4 problems are being given in gate 20 in I understand that is in one of the sets. I don't know, somebody, I asked our colleague to download the gate 2020 question paper, and he has sent me the question paper, and our colleague Mr. Hussain Wali has solved those problems. I asked him to just give me the solutions, and I will go through that, verify that, and try to consolidate those things. But I will not give the solutions. Tomorrow I will give the questions to you. I hope to give the questions, and you can note down that. And when it is uploaded, you can do the problems, and the last day I will discuss that. So let us have the confidence, so that because anyway those solutions are not available. We may be wrong. We may be wrong. Okay. So that need will be justified, and we have to verify that when the solutions are being given by the gate people, or if they have given, because like competitive exams, if when before results are being announced, if they have given the solution, that can be tallied with that. But 4 solutions, 4 sets will be there. So I have taken only one of them. I do not remember which set is that, but definitely I want to make this useful. This one, last day, last 1 hour, I want to solve those 4. I want to give you as a home assignment tomorrow with the knowledge which you have got now. You do those 4 problems on your own, and we will consolidate the results, and we can debate that as a question subsequently. Right? So that is our remaining 3 days lecture plan. So this is RL series circuit. I want to start with the DC transients. That is why it takes a lot of time, because for every topic you need a transition and a change over అంటాం. Transition. ఒక టాపిక్ నుంచి ఇంకో టాపిక్ వెళ్ళేటప్పుడు మధ్యలో కొంచెం గ్యాప్ ఇవ్వకపోతే కంటిన్యూషన్. Based on my experience, I found that is useful, because continuous గా monotonous గా చెప్పుకుంటూ వెళ్తే అర్థం కాలేదని ఇదివరకు స్టూడెంట్స్ చెప్తే దాన్ని నేను చేంజ్ చేసుకుని నెక్స్ట్ ఏం చేయబోతున్నాము, ఇప్పుడు ఏం చేసాం, ఇంతకుముందు ఏం చేస్తాం, లేకపోతే ఏం చేయాలి రేపు పొద్దున అని కొన్ని చెప్తూ వస్తూ ఉంటాం. అందుకని సో దట్ విల్ మేక్ నాట్ ఎ గ్యాప్, బట్ ఈస్ టైమ్ ఫర్ అండర్స్టాండింగ్ దీస్ థింగ్స్. ఓకే, ఎక్కువ టైం కూడా తీసుకోం, 2 to 3 minutes రిక్వైర్మెంట్ ఉంటుంది చేంజ్ ఓవర్లో. సో బికాస్ ఐ హావ్ ఇంట్రడ్యూస్ ది సడన్లీ డీసీ ట్రాన్సియెంట్ అంటే ఏమిటి, ఏసీ ట్రాన్సియెంట్ చెప్పాను, తర్వాత సర్క్యూట్ కాంపోనెంట్ బిహేవియర్ యూజింగ్ ట్రాన్స్ఫార్మర్ చెప్పాను. నౌ ఐ విల్ గో ఫర్ ది సొల్యూషన్ ఆఫ్ ది ఆర్ఎల్ సిరీస్ సర్క్యూట్ అండ్ అదర్ థింగ్స్. సో ఆర్ఎల్ సిరీస్ సర్క్యూట్. సో assume initial condition is 0 at this moment for this particular derivation, and this is a simple electric circuit with V plus and minus that is being given, which is referred to as the DC voltage only. It is also referred as unit step function. Remember, the step function or step disturbance which is used in load frequency control or step disturbance, all these things are essentially unit step function. Here that unit step function is taken as DC function only, because at time t equal to 0 it is suddenly applied, and as time tending to infinity is constant irrespective of the load condition. This is a step function, but this is a transient condition that is being considered in this particular concept. So a step function is being used with unit magnitude is called step function. It is similar to the DC voltage only. It is exactly same as the DC voltage only. So here, but this is being referred to in the signals and system subject. This is being referred to as step function. Okay. So there are various types of other functions also are there. Signal systems is a different subject which I also taught earlier. So this is the one, and you know Laplace transform of this function is your Laplace u of t equal to u of t by s of constant k is k by s. Laplace transform that you are familiar. And so that is a prerequisite topic. Laplace transform becomes a prerequisite subject for this particular chapter to be understood of the transients or differential equation solutions. But we are more popular in electrical engineering. We want to solve more with these things using Laplace transform. Even control systems is applicable. Even classical solution is there in control systems for finding damping coefficients and other things. Okay, same RLC circuit parameters when you have got applications of those things. Okay, so all these things are quite phenomenally same RLC parameters analysis will be done in almost all the subjects. The equivalence only differs with respect to the design of the circuits or design of the machines and other things. The parameter values may be different, but circuit behaviors are differently with RL, RC, RLC combinations only ultimately. Anyway, so now this current under any time for t greater than or equal to 0, that is initial condition IL0 minus is considered to be 0, and for at time t0 plus 2 any time t at t equal to 10 to infinity it is acting as a short circuit. That is different. Okay, so that is the final one. ISS steady state is V by R because it acts as a short circuit. What we were knowing earlier in the first day of lecture is IL0 minus is 0 assuming, and the inductance acts as a the open circuit initially. Under steady state it acts as a short circuit. These two implies that. So that I have mentioned as assumption. So this is the expression for the current. Whether you solve it using Laplace transform solution or differently approach, you are already aware of this one, and the characteristics of the current flowing through that, voltage across that, is exponential decaying function. What is exponential decaying function? All these things you might have studied in RL series circuit with respect to DC transients. I am not going through that things because only one question is being asked in that, and you can see that. And L by R is known as the time constant of the RL series circuit. Because of this time constant, there is a delay in dying down. That is natural dying down of the current in the circuit can be obtained due to the when the voltage source is being removed. It is not instantaneously that it is changing over and current is becoming open, but it takes its own time as according to the time constant of the circuit. So when time tends to 0, it becomes 0. That is implied, but it depends on the time constant. It may reach to some percentage as value. So if time constant equal to L by R equal to 1 time constant T by tau, its value equal to 0.638 or something like that. So like that you can estimate equal to 1 time constant. So for circuit design, suppose you want to get 63.2% of the current to be obtained, like that some value example. Okay, so because e power minus 1 is how much, and 1 minus of that is to be calculated based on that. So L by R is time constant. This time constant will make the energy storage property, that is equivalent to energy storage, because till that time it is actively participating, even if it is fraction of seconds or milliseconds or microseconds, etc. Okay, so at time t equal to 0, when switch is closed, inductance acts as an open circuit, no current flows through circuit, and it's steady state. This is the general input function, right? With this, straight away I will go to the examples. So one or two may be possible. I got about, I think these are page numbers. 6 examples are there. Yeah. So 6 examples I have done for this. And tomorrow I would like to discuss maybe if I complete 1 and 2, 3, 4, 5, 6 problems also I would like to discuss. So if it is uploaded in the corresponding this one, you can come prepared for the problems. Maybe if you try to solve also doesn't matter. So that you can verify these things from the solutions that have been going to be explained in tomorrow's class. Okay. That will be advantageous. It's not that I am giving the material beforehand, but definitely that happens because only complete portion cannot be anyway covered today. Hardly I got another 17 minutes to go. So in the figure, now I would like to solve the problems 1 and 2. So in the figure, this is a gate problem, I think. It's not, yeah, it is mentioned in gate. No, it is given in gate. I think I have not mentioned, doesn't matter. Okay. Okay. When it is given, I have not mentioned, doesn't matter. So in the figure, the switch was closed for a long time before opening at time t equal to 0. The voltage V of x, Vx, given here at t equal to 0 plus, that is at the immediately at the switching at this instant at t equal to 0. So that is, it is not always switch is closed. Okay, the switch is being opened, right? In the figure, the switch was closed for a long time before opening at time t equal to 0. That means initially it is under closed condition. So the corresponding equivalent networks will give you. Then this is current source. This is 20 ohms. This is 5 henries, 5 H, and this is AB terminals, and there is a parallel resistance across this. This is the voltage to be measured is Vx, right? Now the answer, multiple answers are being given here. So this has got no signal directly. It's not possible to guess this one. You need to solve this one, and whichever matches. If you are right, it matches. If you are wrong, also sometimes it may match, but it should not get concluded. But unless you are doubly sure about the correct answer. But anyway, you have to make some guess. So therefore, that is always possible. But guesswork won't work here in this sub topic in this chapter. Okay. So in the figure, the switch was closed for a long time before opening at time t equal to 0. The voltage Vx at t equal to 0 plus is. This is the given circuit, 20 ohms, and is connected across the current source as a shunt element. This is between terminals A, B, where you have to find the corresponding voltage across this one, with polarities that have been shown to be obtained to be identified as minus and plus here. That is, A is a higher potential compared to B. So if the actual one is away from that, naturally it will be taken as minus again. So this is the convention that is given. It has to be plus and minus as given by them. Okay. If it is to be obtained as that one, you reverse that and then say that is a negative of that you will get. So that is the thing. That is why depending on the problem, you have to justify the answers. So that is tricky in this. Okay. So because the first guess is that suppose in the figure the switch was closed, okay, for a long time before opening at time t equal to 0. So this is the short circuit current, right? So 5 henries. Then the corresponding the 25 the 0 answer can be obtained because the circuit is opened at time t equal to 0. Circuit is open. Immediately we will say that circuit is open, so current is 0. Therefore, okay, no problem. Okay. So like that, the answer also people might be tempted to give as 0. Immediate people without understanding, it may happen. It's not that we are doing mistakes. It will be always tempted to give the answers straight away because circuit is open, so answer is 0. Like that. It's not that. Just because how we can predict the answers also. Okay. How our mind can go through that, based on that the corresponding wrong answers also will be given. Okay. Right. So anyway, so another question is 2.5 into 20 is 50. So whatever may the direction, 2.5 into 20 is 50 కాబట్టి 50 volts minus 50 volts. ఏమో ఎలా వస్తుందో తెలియదు. అందుకని మల్టిపుల్ గా 3 ఆన్సర్లు డైరెక్ట్ గా తెలిసినట్టు కనిపిస్తూ ఉంటాయి. ఓకే. సో అందుకని ఏంటంటే గెస్ వర్క్ డజంట్ వర్క్ హియర్. So anyway, now let me come to the actual solution to this. So when the switch was closed, the circuit was in steady state. Okay. So this is the equivalent circuit when the switch is closed in the before the time before it is open. That is called steady state condition. This steady state current will become the initial current at the time of the opening of the switch, where you have to find the corresponding current at time t equal to 0 plus, just immediately after that. That is the meaning of this, right? So that is how these particular things are being considered, right? So that is the meaning of the switch was closed for a long time. That is, steady state current would have been raised in the circuit element. It is not a resistive circuit, it is a combination of the oral combination. So it is inductive current will be shorted under steady state condition. So you can see the switch is in closed position. The switch is in closed position. Switch is yes here. Okay. And that is being represented. Okay. Switch yes. That is the representation that is being made for this circuit. So, and when it is closed under short circuit condition, it is shown as short circuit under steady state condition rather. So now the current flowing through this one is how much? So this is AB and this is the switch, and short circuit takes place through the inductance. So this 20 ohms becomes ineffective. So current flows through this is, current source is here. This 20 ohms also gets shorted because it is directly connected across this one now. So the current flowing through this IL0 minus through inductor is only 2.5 amps. See, a lot of small tricky issues are there. Okay. So by looking at it, if you are able to observe this, it's okay. But you have to carefully understand that the circuit is under steady state condition and it is inductance under short circuit condition. That is a steady state condition, it acts as a short circuit. So this resistance is becoming ineffective and current flows through the least resistance path. So current flows through this particular branch, and also this 20 ohms also get ineffective because across the current source directly this current is being obtained. So the same current flows through that. This also is equivalently shorted. So because of the presence of the inductive property of the element under steady state condition for DC circuit, it is equivalent to a DC circuit. In case of doubt, you convert this independent current source into a voltage source because it is practical voltage source, right? It is a practical voltage source. So it is a DC transients. So it is equivalent to simple RC RL combination with L and R prime being parallel in this particular branch, and this is a voltage source only, right? And the practical voltage or current source can be converted to voltage source, or practical voltage source can be converted to current source. These are some of the key issues. Okay, so it doesn't matter whatever the way that is being given. So otherwise also you can take this as a 2.5 and 20 is 50 volts is a equivalent source transformation technique you can use in series with the 20 ohms, and this particular one is being transformed. So 50 by 20 is 2.5 flowing from this. So flowing through AB, right? So that is how you have to think. Either way it is same. Okay, whether you are conversant with directly current source, if it is a practical current source, it is always easier to use the source transformation, do it voltage sources, because we are more conversant with the voltage sources. Okay, so that will straight away give you 50 and 20. So 50 by 20, that is 2.5 amps. That is how this current source is being mentioned, and that is the data. Okay, so anyway, so the initial current through the inductor is only 2.5 amperes. That is obtained like this. And you see, I think it is maybe given for 1 marks question. I think in way back somewhere I can refer to that at a later stage. I will tell you. Its textbook is with me. Anyway, it doesn't matter when it is being given, but having done that, and I did not mention it, that's why I just in oral series circuit. Okay. Just a few seconds, because already it is being given, and I thought I must mention it so that it will be advantageous for you also subsequently. Yeah, it is given in this is different. Okay, don't worry about when it is being given. Because I refer to one textbook only, but anyway, it doesn't matter. So I will get back to you sometime tomorrow. Anyway, this is only to show that this is a gate solved problem. So this is I is equal to 2.5 now, and the switch is in other position. Okay, this is steady state current is obtained in case 1. The other one is when switch is closed at time t equal to 0. Now this is equivalent circuit. You can see under steady state condition, inductance acts as an open circuit. Now you can see the inductor current is flowing through this, right, with the polarity, right, and the directional current is like this. Okay, this is the corresponding one. So that means L into I0 minus would have been this one, but anyway, the current is now is being there because the circuit is open. This inductor current will be there for some time. So this is 2.5 into 20 when the switch is closed at time t equal to 0. Now this Vx, so in the direction of the current, this is the current flowing through this. Okay, so this is 2.5, and this is the only loop that is being available because the source is cut off, and the switch is closed under steady state condition at time t equal to 0 plus. The corresponding initial current will be, this will be open circuited. The equivalent circuit becomes, although the circuit is opened at time this one, so this particular portion is open, so this current is now becomes only one loop here. So 2.5 into this, the polarity of this one will be in the direction of the current, there will be a potential drop. So V will be at higher potential compared to A. So but Vx is required to be obtained in opposite direction, minus and plus. So therefore that is obtained as minus V. So our notation is like obtained like this. The actual direction that is required by the question is minus and plus. So therefore the value of the V that is computed should be reversed to get the value of this particular minus and plus. So according to the question and the notation that is being given, and what is required is that A should be at higher potential, then this should be minus V. So minus 50 volts is the answer. Okay. So because A is to be obtained as the higher potential, B is to be obtained as this one. So in the actual direction, this one is this, but this is given a assumed one. This is given in the question is assumed one. The actual one is computed like this. So therefore it has to be minus 50 volts. That is the meaning of this. So that is why changing the signs is to be careful. ఎప్పుడు చేంజ్ చేస్తాం ఎప్పుడు ఎక్స్ట్యూమ్ చేసుకుంటున్నాం అనేది ప్రాబ్లమ్ బట్టి మీరు అర్థం చేసుకోవాలి అది నాట్ దట్ దే ఆర్ బీయింగ్ చేంజ్డ్ ఓకే ఎనీవే సో దట్ ఈస్ ఆల్వేస్ ట్రికీ ఇష్యూ సో okay, I think I can go for 7 minutes is there. I can go for one more example. Yeah, this is a typical but simple problem. Now seem to be complex, but it's not so. For the RL circuit shown in the figure, the input voltage VIT equal to U of t, that is step function. The current IT over figures the data icharu. Now what is required is to compute at what time. Okay, and చూసుకుని దేనికి టాలీ అవుతుందని చూసుకోవాలి. So this is the characteristic curve of the current response that is well known for RL series circuit with the step function that is being given. Okay, so the formula for that is I of t equal to V by R into 1 minus e power minus t by tau. That is known to us. So based on that, under steady state condition, it reaches to the corresponding steady state value, either this value or this value, doesn't matter. This is the characteristic. Curves are the same, characteristic curves are the same. It is simple RL series circuit only. The circuit is given here. 1 Henry and 2 ohms. So now, what is the steady state value? What is the value of the corresponding? It tallies with half second దగ్గర అంటే 0.5 సెకండ్ దగ్గర టాలీ అవుతుందా లేకపోతే 2 సెకండ్ దగ్గర టాలీ అవుతుందనేది చూసుకోవాలా మనకి చేసేదాన్ని బట్టి ఇచ్చిన క్యారెక్టరిస్టిక్ కర్వ్ లో. సో ఇక్కడ 0.5 ఆంప్స్ కి 1 ఆంపియర్ కి చేంజ్ చేశారు 1 into 4 ఫిగర్స్ లో. ఇక్కడ 0.5 ఆంప్స్ స్టడీ స్టేట్ కరెంట్ కి ఇక్కడ 1 ఆంపియర్ ఇచ్చారు. ఇక్కడ హాఫ్ టైం కి ఇచ్చారు హాఫ్ సెకండ్ కి విత్ 0.31. ఇక్కడ హాఫ్ సెకండ్ కే దీనికి డబల్ ఇచ్చారు 0.31 ఆర్ 0.63 62 ప్లస్ ఉంటే దాన్ని రౌండ్ చేసి ఉంటారు. సో అండ్ ఇక్కడ హాఫ్ సెకండ్ కి 0.5 0.31 అంటే ఈ రెండు సిమిలర్ గా ఉన్నాయి. అండ్ 1.63 బట్టి దిస్ టీ ఈజ్ ఈక్వల్ టు 2 సెకండ్స్. సో ఇవన్నీ కూడా ప్యాటర్న్ మ్యాచింగ్ ప్యాటర్న్ రికగ్నిషన్ చేయాలా చేసి ఏది అనేది మనం మైండ్ లో పెట్టుకొని RL series circuit ప్రాబ్లమ్ ని సాల్వ్ చేసి దేంతో మ్యాచ్ అవుతుందని చూసుకోవాలా. సో ఇట్స్ ట్రికీ ఇష్యూ రైట్ బట్ యూ కెన్ ఈజీలీ గెస్ దట్ విచ్ వన్ ఈస్ టు బి ఎలిమినేటెడ్. సో దిస్ ఈస్ VI of t యూనిట్ స్టెప్ ఫంక్షన్ కాబట్టి DC వోల్టేజ్ వోల్టేజ్ దట్ ఈస్ బీయింగ్ గివెన్ ఈస్ వోల్టేజ్ UT అంటే యూనిట్ స్టెప్ ఫంక్షన్ అని U of t అంటేనే యూనిట్ స్టెప్ ఫంక్షన్. సో దట్ ఈస్ 1 into UT magnitude is 1. సో స్టడీ స్టేట్ కరెంట్ ఎంత వస్తుంది స్టడీ స్టేట్ కరెంట్ 0.5 1 అనేది ఈ రెండింటి బట్టి తేలిపోతుంది. బికాజ్ ఏఎస్సిలో 0.5 ఇచ్చారు బిఎన్డిలో ఓకే బిఎన్డిలో దిస్ ఐ హావ్ నాట్ రిటన్ హియర్ దిస్ ఇస్ బిఎన్డిలో 1 ఆంపియర్ ఇచ్చారు బట్ దిస్ ఇస్ 1 divided by the steady state current will be inductance acting as a short circuit 1/2 is 0.5. Okay, so we can tally with these two. So ఈ రెండు కాదని తేలింది ఇప్పుడు స్టడీ స్టేట్ కరెంట్ కాదు. స్టడీ స్టేట్ కరెంట్ ఇస్ ఈక్వల్ టు హాఫ్ ఆంపియర్ కాబట్టి because that is well known unit step function 1 volt 1 divided by 2 is half. So this is half ampere 0.5 amperes ఏ సింపుల్ వేయలేదు సారీ యూనిట్ వేయలేదు. ఓకే సో at t equal to infinity its value equal to half ampere. ఓకే నౌ ఈ రెండిట్లోనే కావాలి. ఈ రెండిట్లో ఇంక మళ్ళీ 2 amp దగ్గర నువ్వు క్యాలిక్యులేట్ చేయక్కర్లేదు మనం క్యాలిక్యులేట్ చేయక్కర్లేదు. సో you have to tally with either this value or this value. That is a process of elimination లో మనం సాల్వ్ చేయాల్సి వస్తుంది ఈ ప్రాబ్లమ్ ని. 4 ఉన్నాయి 4 క్యాలిక్యులేట్ చేయాలని అక్కర్లా మనం ప్రాబ్లమ్ ని సాల్వ్ చేస్తూ పోయి ఎక్కడో చోట బిగిన్ చేసి we know easily the steady state current. So that is equal to half ampere because unit step function అంటే magnitude 1. Okay, by definition. So therefore the steady state current equal to 1/2 is 0.5 ampere. That is straight. I don't have to worry about it. సో ఇక్కడ ఈ రెండు ఫిగర్స్ తో అవుతుంది. సో రెండు హాఫ్ దగ్గర ఇచ్చారు కాబట్టి t equal to half now I have to compute 0.31. సో e minus 1 0.63 0.682 ఎంత వస్తుంది. సో దాన్ని బట్టి ఇది వస్తుంది 0.31 1 minus of that కాబట్టి డివైడ్ బై 2 కదా. ఓకే సో ఎనీవే దట్ ఈస్ 0.316 అనమాట 0.316 1 minus of that 0.682 డివైడ్ బై దట్ 0.3 సంథింగ్. ఓకే సో ఆన్ హ్యాండ్ అందుకే ఒకసారి చెప్పడం కష్టం బట్ e power minus 1 is nothing but equal to 1/e. 1/e is standard value. Okay, so anyway so that is how you can tally with this. So 1/2 steady state the formula is known V by R into 1 minus e power minus R by L and t. So R by L is time constant, L by R is time constant. So అలా వేసుకున్నా సరే R L సబ్స్టిట్యూట్ చేసిన e power minus 2t వస్తుంది. time is equal to now half second కాబట్టి e power minus 1 వస్తుంది. So direct substitution of this quantity is yielding 0.31. So 0.31 ఇక్కడ 0.5 amps ఇచ్చారు. ఇక్కడ మనకి రెండు టాలీ అవుతున్నాయి, మల్టిపుల్ ఆన్సర్స్ ఉన్నాయి దీనికి. Yeah, seem to be my god. Okay, I will clarify that subsequently also. Let me 1 second. అయిపోతుంది, 5 అయిపోతుంది. Okay, 1 second. Let me check this. Oh yeah. So it is probably those days two choices are correctly given. So I am not wrong. I have written correctly. So A and C are the right answer, surprisingly to this. So it is yeah. Now I could get it. 2004 problem given is for 1 ampere, 1 mark question. So this is a typical problem that way. Okay. So I mean there are two choices for this. Okay. Maybe there is a error in the textbook. Otherwise, the answer is both are. I made a mistake here. Now I got the point. It cannot be like that. Yeah. Sorry. This is 2 seconds. Just as yeah, A and D are being given for 2 seconds. That is what. So there is a mistake. So this is only 2. So therefore, it has to tally with one of these things. Half it is luckily tallied. Otherwise, I would have solved for 2 also. That is why answer is C. Now I am clarifying you. This should be 2. So while writing down, I made a mistake here. So that is what it can happen. Anyway, if it is sometimes given, even multiple choice questions are also being given for 2 questions earlier in one of the competitive exams in GATE also. That is, there will be 2 solutions directly. So you both are given only, you are given 2 marks, otherwise 0. So such things can also, we can conclude. Even wrong answer can be concluded like that. But this I made involuntarily, అంటే అనుకోకుండా మిస్టేక్ చేశాను ఇక్కడ, కావాలని చేయలేదు. So while writing down, copying down the question, I made this wrongly. This is given as 2 seconds. So it is question number 4.7 that is given in the textbook, the solved question paper book, Made Easy Publications book for electronics engineering. Okay. So therefore, anyway. So these are the 2 problems, and I think we are finished with the time. So I will just briefly mention for 1 minute that I tried to explain the DC transitions with respect to the Laplace from some variables, and I have started with RL series circuit configuration, and we know the I of t equal to V by R into 1 minus E by R minus R by L into T, and this is unit step function is DC voltage only. So transition analysis or a response with respect to step function is also one and the same. And the steady state current is known is V by R. Inductance acts as a short circuit, and inductance acts as an open circuit initially. This is the expression for the current at any instant of time. L by R is the time constant of the circuit, and I have explained the properties of the circuit elements with respect to the transformed parameters. Okay, so that is why these chapters are very, very tricky. So it takes a lot of time for explanation, and I could nearly spend 1 hour for this. But I have explained in the symbols and solving just 2 problems only. But anyway, they are all tricky. Even I made a small mistake here. This should be treated as 2 seconds. Then only anyway. So it is tallying with C. It is possible. If it is suppose it is right, then you should say must be confident that there are 2 multiple answers for this particular question. Earlier it was given like that. So it is not deliberately done. I made a mistake here, but that can be rectified, and that original question I verified now. Okay. Anyway, So tomorrow I will continue with this, starting with the examples 3, 4, 5, and 6. Maybe they may upload by tomorrow or today, I do not know. So if they upload in the website, you can see that, so that you can be prepared for solving these particular problems. And tomorrow I will discuss RC series circuit. Also it is there in this. So for the presentation today, I have done so many good number of examples. There are 8 examples are being given. So 8 plus remaining 4, 12, and RLC I got 2 to 3 out of the all gate question papers only. But gate question papers, all problems only remaining. So I hope it will be interesting for you. But see how much I am involved in this. I suggest you mentally prepare for this. If they are put in the website by tomorrow morning, hopefully, then you can prepare for these things so that you can understand much better instead of listening and then studying later. You prepare first and then listen later. Perhaps then refer later. Then it will be threefold. So that's how it is will be advantage. That is why conventional teaching of listening, writing, and then studying at a later for the exam, it will be threefold. So now it is similar. Because already the subject is familiar to you, I suggest you prepare these topics well in advance. That is for tomorrow's this one before I start, because this is going to be uploaded. Because a part of it, complete sheets are being now uploaded to be uploaded, and I will send the email to the admin people now before we close the session today. So therefore, you can prepare for these things. You can see good number of examples are being given, so that I suggest although solutions are available, you take these examples and then try to solve independently. Be honest in doing that. Honestly, because we will not get the confidence that we can do it independently. Okay, so then you can listen to this. Then there are a good number of enthusiastic people are there. That is where I am telling the way you have to solve the problems. Okay, so you be attentive in these things because these are very tricky subject, and constant గా మీరు నా సజెషన్ ఏంటంటే గేట్ ది రోజు గంటన్న చేస్తూ ఉండాలి ఖాళీ ఉన్నప్పుడు. అంటే బికాస్ మళ్ళీ ఈ పాండమిక్ పీరియడ్ అయిపోయి క్లాసెస్ స్టార్ట్ అయ్యి ఎగ్జామ్ స్టార్ట్ అయ్యి అంటే ఒక 2 months గ్యాప్ వచ్చేస్తుంది. మళ్ళీ నెక్స్ట్ సెమిస్టర్ స్టార్ట్ అవుతుంది. మళ్ళీ నెక్స్ట్ సెమిస్టర్ ఎగ్జామ్స్ లో బిజీ, దాంట్లో బిజీ. మళ్ళీ నవంబర్ డిసెంబర్ వరకు మీరు దీన్ని ముట్టుకోకపోతే మొత్తం అన్ని దాన్ని ఏమంటారు రీవైండ్ అయిపోతాయి. సో నలిఫై అయిపోతాయి. మళ్ళీ యూ హ్యావ్ టు రీస్టార్ట్ ది టేప్. సో యూ హ్యావ్ టు రిమెంబర్ దోస్ థింగ్స్, అండ్ మధ్య మధ్యలో ఖాళీ వచ్చినప్పుడు ఒకసారి గుర్తెచ్చుకుంటూ ఉండాలి. Okay, anyway, these are some of the tips for making good preparation for your GATE examinations. ఈ చాప్టర్ అనే కాదు, ఎనీ సబ్జెక్ట్, ఈ టాపిక్ అనే కాదు, ఈ చాప్టర్ అనే కాదు, ఎనీ టాపిక్ యూ షుడ్ బి ఏబుల్ టు డూ లైక్ దట్. సో దే ఆర్ టోటల్ 18 pages, out of which I have just discussed up to 2 problems, means in oral circuit only. So this okay, from 10th, this continuation to the RC circuit. So ఇక్కడ సెకండ్ ప్రాబ్లం 5 వరకు చెప్పినట్టు. సో దిస్ ఈస్ 2. ఓకే, ప్లీజ్ కరెక్ట్ ఇట్. సో మిగతా 6 నుంచి 18 వరకు ట్రై చేస్తాను కవర్ చేయడానికి. ఐ విల్ యాడ్ సమ్ మోర్ టాపిక్స్, ఆర్ఎల్సీ సిరీస్ సర్క్యూట్ ఆల్సో. సో దిస్ ఈస్ ది ఫర్ టుడేస్ టాపిక్, అండ్ ఐఎమ్ గోయింగ్ టు వైండ్ అప్. Admin. So I thank acknowledgement I would mention. I thank the university authorities, Honorable Vice Chancellor and the DAP for, and State Council of Chairman Professor Hemsra Reddy, and the other staff, faculty who are helping me, and Surendra, Dr. Bharat, and other lady staff who are in the admin section for making this Google Meet and also the video lectures coverage through YouTube. All these things are parallelly they are there in the office, and so I thank everyone for giving the opportunity. Tomorrow, please be available by 2:55. We will start at 2:59 or so, and we'll have the continuation of the DC transients. And if this is uploaded, you can come prepared for these things, for the DC transient remaining problems, and also for series circuit, of RC series circuit for solving the problems in transients.